one. So you can watch it three ways. You can watch the class in person, you can watch the class via WebEx synchronously, or you can watch the recording asynchronously. And it only meets in person on Mondays. For the rest of the materials will be posted online. So I'll have some of the materials I would have if this was exclusively an online class, I'll have posted, plus we'll also have the in-person lecture. And you can mix and match, you know. A couple people told me just because the weather was bad, they didn't want to drive in, and that's great. You know, with the pandemic, if you get ill or whatever, you can watch the lecture either synchronously or asynchronously. For those of you that are watching remotely, if you do have a question, just unmute your mic. I think you're allowed to, and just shout it out when I ask, are there any questions? All right, what I like to do now is talk a little bit about Java classes. Because in the recorded lecture last week, I talked about Java classes, and I said all your code is going to be in a Java class. All right. One thing to keep in mind, I may say all or whatever. Just read that in general as being most of the time, right? Or typically, might be a better way to put it. But code is going to appear in classes. And we're going to have two kinds of classes that we're going to be worrying about in this class, this course. First one is the boss class. The second one is, sometimes they're called business classes, because so much of programming is done for business applications. They're called business classes, but really a better term for them is problem domain classes. The boss class is the class that runs the show, right? So if you remember from last week, we talked about there needs to be at least one class that has a main method in it. All right. The boss class is going to have the main method in it. And my apology to the bosses in the world, but generally, our boss class doesn't do the work. All right. It creates and uses other classes. Create or uses other classes to do the work. Our business classes or problem domain classes are the ones that actually do the work in the application. So for example, if I had a student system, if I had a system for college, I would probably have a student class. I probably would have a course class. I probably would have a professor class. I might have a department class. All right. I might have a grades class. All those things are part of the problem, right? Grades, professors, students are part of the problem of running a college computer system. There are things where you have to do some work, to do calculations or whatever, right? So those classes are the problem domain classes, all right? The boss classes might be things like the GUI that we run, all right? Where it doesn't do the work itself, but it allows you to create a student object and do some calculation and enroll a student in a class or give a student a grade or something like that. All right. So in our class, we're going to have two kinds of boss classes.
Professor Zellers, you're not sharing your screen.
I'm not sharing the screen. Thank you.
Thank you.
All right, I was not sharing the screen. This is what I've written so far on the screen, that we have classes, one of which is a boss class, which there's a main method, doesn't do the actual work, but uses other classes to do the work. And then we have business classes or problem domain classes that actually do the work. We're going to have two kinds of classes in two kinds of boss classes. Initially, for the first main part of the semester, for probably the first 2/3 of the semester, we're going to have what are called unit test classes. All right. Unit test classes use the problem domain classes and test them out to make sure they do what they're supposed to do. All right. So for example, there might be a student class that has a calculate tuition method in it, right? Or function. I use the word method and function synonymously. So there might be a student class that has a calculate tuition function in it that uses the formula for calculating a tuition for students. That depends on where they live, their residency status, and how many credit hours they're taking. Well, there's right and wrong answers to that, right? You have to make sure that the business class that you develop, the student class, works. In that case, your unit test class would have a series of test cases to make sure that the calculation was done correctly, right? These would be hard-coded, all right? I know hard coding is sort of a bad word in programming. Usually we don't like to hard code, but in a unit test class, that's acceptable because the unit test class would not be part of our finished application. It's just used to test out our problem domain classes. The other kinds of boss classes we're going to be using are GUIs. And about 2/3 of the way through the semester, we'll talk about GUIs. So that's where we're going to be more like a real application, where instead of hard coding that a student lives in Lorain County and takes 12 credit hours, we're going to actually have a GUI that you would allow the user to pick how many credit hours a student was taking and put in their residency status, and it would calculate that. Okay. So the unit test is going to create and test the business classes. It's called a unit test because it's part of a testing strategy where individual developers develop their classes. Like if we did a giant system for a college, maybe you'd be assigned the student and professor class. Maybe you'd be assigned the course and department class. Maybe other people will be assigned the room class or the building class or whatever. Well, you want to make sure your work works, right? You want to make sure your code works. So you would test your classes individually. That's called unit testing, where you teach a component. Then there is system testing, where you put everything together and make sure it works as a unit. Because you might write the code correctly the way you think it should be, and you might write the code correctly the way you think it should be, but when you put it together, there's a conflict somewhere. One of you guys assumed one thing, or one of you guys assumed something else. All right? So because of that, you first do unit testing, where you test your pieces of the puzzle independently, and then you do system testing. So the classes we're going to create a unit test class, and that will test our business classes that you're developing. Later on, we'll create a GUI that will also use the business classes. So some of this might be confusing to you. Let's look at an example. All right. And we're going to use an example that's near and dear to my heart. Right? We're going to do an example assuming that we are a pizza shop and we make pizzas. So right now, we're going to have one unit test class, and we're going to have one business class. And our unit class, our unit test class is called, cleverly enough, that's CISS216. Our unit test class is called unit test. All right, clever. All right, our pizza class is called pizza. Now, just to review what we talked about last time, we create our classes following the rules of Java. We must compile those classes before they're run. So the Java classes are the ones that you create and you enter the code in. Those get compiled to the .class file, and those get executed. So let me go to the command line, and let me do that. CD means change directory. So change directory to the desktop. I forget exactly what it was called, but I know it starts with pizza. So I'm going to type in CD to change directory to the pizza directory. Type in a dir to see my list of files. Okay, we're in the right place to test this. So to compile my code, I can type in Java C, and I could type in unittest.java, or I could just say .java. All right. We don't get any answer. This is the case of no news is good news. The fact that I compiled it and I didn't get any error messages means that it compiled correctly. It's a little, how do I want to say that? I kind of wish it told you, hey, congratulations, you compiled it cleanly, but it doesn't. All right. How do you know it compiled completely? Well, if you don't get an error message. Or the other thing you can do is you can look at the date and time of the class file. So the date and time of the class file is 1:13 p.m. today, and that's about what time it is right now, 1:14. So it finished it a minute ago. To run it, I will type in Java and the name of my main method. So I'll type in Java and I'll type in unit test, which is the main method. And it goes and it says the first piece of size is large. First piece of crust is thin. First piece that has pepperoni is false. The bake time is 10. For the second pizza, the bake time is 16. For the third pizza, the bake time is 10 again. So what this pizza class does right now is it shows how long it will take to bake the pizza. Now that depends on, the size of the pizza, or maybe it depends on the kind of crust. I forget how I coded it. Okay? So let's start out by looking at the pizza class. And we're going to make some observations about that class. All right, first of all, public class pizza. Most of the classes we do are going to be public. That simply means it can be used by other classes. Very rarely would you have a class that was not public. Possible, but for what we're doing, probably not. Notice that the class name pizza starts with a capital P. That's sort of a Java convention. All your class names should start with a capital letter. And it should match the name of the file. And it should match the name of the file exactly. So for example, if we look, the name of the file is pizza with a capital P-I-Z-Z, capital P-I-Z-Z-A .java, and the class name is pizza with a capital P. So it should match, including the case. All right. So that's our class. We use these, I just heard these called as flower brackets. Never heard that term before, but I usually call these braces or curly brackets. All right. Notice the braces go around things, sort of group things together. In this case, I have a brace at the beginning, and I have a corresponding end brace at the end. That means everything between there and there is part of the class. Okay? Classes contain mostly two things. They contain attributes, and they can include methods or functions. An attribute is a quality or a characteristic of the entity that we're developing a class for. I said before that these are problem domain classes or business classes. For the most part, entities within that business environment have classes created for them. Or I should put relevant entities. Going back to the school example, students are relevant entities to a college. Important thing of the college, right? Two, professors are an entity of the college. Classrooms are an entity of the college. Courses are an entity. Now, you might say, well, are chairs an entity? Oh, probably not important for running a college to keep track of chairs. Maybe it is. But you might say, well, that's not really relevant to what we're trying to do. So you don't literally have a class for everything, all right? It's only if it's relevant to the problem that you're trying to solve. All right, so in our case, I've defined three attributes. Size, crust, and whether it has pepperoni or not. I've simplified this example to just say there's only one possible topping, pepperoni. It either has it or it doesn't. Let's look at these attributes more closely. Starts with the word private. And that's a good practice to follow. Make your attributes private. Later on, we'll learn about protected, which is also okay. But you make your attributes private so that no other classes outside of this class can access these attributes directly. That's a good practice because you don't want other classes that maybe don't know the right value for setting these things of going in and setting the value incorrectly. So how do you access these attributes then? You do it through functions. All right. We'll look at those in a minute. At the word private is the type of variable it is. String, notice, starts with an S, a capital S, that is. Boolean starts with a lowercase b. We'll delve into more about the differences between these two things. Why does one start with a capital and one start with a lowercase level? The lowercase level are what are called primitives. Those are very simple data types. For example, a Boolean is a data type that just has a value true or false. Other variable types include ints, double or double precision values, decimal, character. There's maybe a dozen or so primitives. You can tell at a glance whether something's a primitive or not based on whether the name of the data type starts with a lowercase or an uppercase. So if you had an example you never saw before, and assuming the code was correct, if that data type started with a lowercase letter, is a primitive. String doesn't start with a lowercase letter, it starts with an uppercase letter. That means that strings are objects. And therefore, there are different kinds of variables. They're not primitives, they're object references. We'll talk a little bit more about, we'll talk a lot about this, to be honest. What an object reference is and so on. But file away for later that strings are objects. All right, let's look at the rest of this class and we'll make some more observations. Typically, for each attribute, you're going to have a set method and a get method. And these are going to be public because someone has to be able to change the value of those attributes. We're just forcing people to go through the appropriate channels to change them and not change them directly. Right? Set methods set the value of an attribute. The set method is typically going to be named set and the name of the attribute. The name of functions are typically, the format of that name is called camel case because the first letter is lowercase and each subsequent word is uppercase. So for example, set size. The S in set is lowercase, the S in size is uppercase. Set crust. And finally, set has pepperoni. This is the return value for the function. These classes, or these methods rather, don't return anything. Therefore, you indicate that by saying void. So if you see public void, then the name of something, that's a method that doesn't return a value. In parentheses are the arguments. And the arguments are going to be the type of argument and the name of the argument. So in this case, what we call the set size method, we're going to give it a string, and whatever that string is, it's going to set the size attribute of this particular pizza to the argument you gave it. Now, you're going to notice something real quick. I'm just going to tell you, don't worry about it for now. There's no validation here yet. So normally, we would make sure that you could only set the pizza size to an appropriate size code, small, medium, or large, or whatever the organization will. We're not going to worry about that right now. Later on, we'll worry about that. Same thing with set crust. Same thing with set has pepperoni, except the argument there is a Boolean. So the argument is going to be whatever type this guy is declared, because it has to match up. The value that you give this function has to be put in this variable. Okay. You then have get methods, and get methods return the value of a variable. All right. And the type that is returned is the type of the variable. So these two return strings. This one returns a Boolean. So get size returns the size attribute. Get crust returns the crust attribute as a string. And finally, get has pepperoni returns the Boolean that contains that. An important object-oriented term is encapsulation. Encapsulation means that everything about an entity is contained within the class. And that nothing from the outside classes can manipulate the attributes without going through the methods. There's also another name for that. I don't remember what it's called. Data hiding, I think. In other words, the outside world, by outside world, I mean other classes, can't access the attributes directly. Those are hidden. The only thing that they can do is call methods on the class. Now, last but not least, I have calculate bake time. And it's a real simple formula here, where if the crust equals to thin, then it takes 10 minutes to bake it. If the crust is not equal to thin, it takes 16 minutes to bake. I just made up those numbers. Oh, that sounds about right to me. Notice I don't say equals like this. I'm not going to go into details why, but in a nutshell, we can't say equals like that because string variables are object reference variables. And if we do this, it's not going to give us the results we think. So this is how we compare strings. If the string variable dot equals, and then we have another string value in there. That's how we compare strings. And that will work the way that we expect. All right. So what do we have in this class? We have attributes and methods. That's typically what we have in classes. All right. The attributes are properties or characteristics. The methods are things that can be performed. And they have return values and they have arguments. Arguments is what you give to the function. Return values are what you get out of the function. Let's look at the unit test. Now the unit test does what? It tests our business logic class, problem domain logic. So it might not necessarily have any attributes. It will definitely have the main method though, because that's what gets run when we run our Java application. We have to have at least one main method to run our Java application. Let's look at this statement right here. We're going to spend a lot of time on this single statement, not necessarily today, but throughout the semester. But I do want to introduce you to what this does and a couple of key concepts. Pizza over here is a class. What do I mean when I say something is a class? Does anyone know? Right, right. Is things, a class is sort of a template for a particular entity where every member of that class has the same attributes and the same function. You can do the same thing to them. All right. Every pizza has these attributes. Every pizza has a size. Every pizza has a kind of crust. At least at this pizza company, it does. And every pizza can have pepperoni or not. All right. Those are just attributes that everyone has. If we talk about a student class, all students have student numbers. Students have first names and last names. They have an address, city, state, and zip code. They have an email address. They have a phone number, and so on down the line. All right. Professors have first names, last names, email addresses, offices, departments that they work for, and so on. So the attributes are things that all members of this entity have in common. And the pizza class represents all of these entities. All right. It's a template for each of the entities that belong to this type. Methods are things that you can do to every member of the entity. For every member of the entity, we can define what the size is. That is, we can set the size. We can get the size of every member. We can set whether it has pepperoni or not. We can get that. We can set the crust type. We can get that. And lastly, we can ask how long this pizza takes to bake. Now, Keep in mind that it is noted that not every pizza is going to have the same value. Just like every student doesn't have the same first name, last name, email. So every student doesn't have the same email address, but every student has an email. Now that is a class. A class is a template for members of a certain class or group of entities. An object is one particular instance, all right, of that. In other words, a class could be pizza. An object would be the small pepperoni pizza with thin crust that I ordered a minute ago, all right? A specific member of that class. The professor is a class in a college system. Mike Zellers, whose office is BU211J, email address mzellers@lorainccc.edu, is a member of that class. Therefore, you could have an object representing the one member of that class. So the class is a template for all the members of that class, all right, all the members of that entity type. An object relates to one of them that has its own particular values for the properties. So when I say this here, I'm saying, let me make a pizza. We're going to call that pizza new 1 or pizza P1. And we're going to make that by creating a new object using the pizza class as a template. So I have a pizza. This pizza's name is P1. It's a brand new pizza that I'm creating. It's not a pizza that I created before. And I'm using the template in the pizza class to make this pizza. Again, with the conventions, notice that wherever you see pizza with a capital P, you're referring to the class. The object is typically referred to by a lowercase. So again, that's a visual cue to help you understand this. I have a member of the class of pizza. And it's in this member or this object that I'm creating is called P1. And it is a new member of the pizza class. I then have a list of sets. When I say P1.setSize L, I'm setting the size of that pizza that I just created. Not setting the size of every pizza out there or the next pizza that I create or whatever. I'm simply setting the size of that pizza that's named P1. Setting it equal to L. Second line, P1.setCrust equals as thin. I'm making the thin this crust attribute of P1 equal to thin. And finally, I'm setting that it does not have pepperoni. So I'm using the set functions to set those attributes. Right now, there's no validation, but later there will be. Right? I cannot say P1 has pepperoni equals true because those attributes were defined as being private. I have to use the method to access and manipulate that property. So what I've done is I've created a pizza that initially is blank. It has no values. Now in here, I'm saying that the pizza that I just created has a size of L, has a crust of thin, and it has no pepperoni. Now here, I'm simply outputting that. System.out.println is the command to output to the console whatever is within these parentheses. So the first pizza size is, and I pull up P1 get size. So that is going to access that size attribute and return it. So I set it to L, it's going to have a value of L. If I set a value of L here, and when I did the get size, it returned an M, then something didn't work right. Okay? So this is why it's called a unit test. Same thing with crust, same thing with has pepperoni. And finally, bake time. Now, what should the bake time of this pizza be? Well, if I remember, I said it takes 10 minutes to test or to bake a thin crust pizza. So when I run this, it better say 10 minutes. I'm going to go put a couple extra instructions in here. I create a second pizza. Same way. It's a brand new pizza. Doesn't have anything to do with that first pizza created, except because it's a member of the same class, it has the same attributes and methods. So I create the new pizza, I set the size to equal to L, I set the crust to thick, and I set has pepperoni to false. I then output the values for that pizza. And so on down the line. So how many pizzas did I create? I created 3 of them. Their names are P1, P2, and P3. How do you know how many pizzas I've created? Because there's 3 new statements. New pizza, new pizza, new pizza. Every time you say new and give the name of a class, you're creating a new instance of that class. That is, you're creating a new object of that type. So let's compile it and run it. One thing that's really neat is you can use the arrow keys to bring back old instructions. So for example, I'm not going to type in Java C, I'm going to hit the up arrow twice. All right, and it just brings up that what I typed in 2 commands ago. And I can just hit enter and it recompiles it. If I do that twice again, oops, hit the down arrow to get to it, I can run it. This pizza is thin crust, 10 minutes bake time. This is thick crust, 16 minutes. So this passed my test because every pizza I created thin and thick crust, and it gave me a correct value for the bake time. Could I test this pizza object by only creating 1 pizza? No. Why not? It wouldn't test every condition. Your goal is to test every possibility. And in fact, what I will do probably for some assignment is I'll have you create a test plan. The test plan for this might be test a thick, create a thick crust pizza, create a thin crust pizza. Check the times. The thick crust should be 16 minutes. The thin crust should be 10 minutes. If I just tested thin crust and it came up as 10 minutes, well, that's good. But if I don't test the thick crust, maybe it just gives every pizza 10 minutes as the bake time. Don't know that. So you would test every possibility that exists. That's relevant to the thing that you're testing. All right. Any questions about this so far? Let's look at errors you can make. I kind of wish I could turn the screen off for a second. try this. Yeah. Okay, I did turn the screen off for a second. I'm going to make a mistake and we'll see if we can figure it out. Learning how to read error messages is a skill into itself. Remember, I'm here to help you. So if you get an error and you don't know what it means, by all means, feel free to ask me. But do spend some time trying to figure it out on your own. So I put an error in somewhere in the code. And I'm going to compile it. And let's see what we get. Here's a popular error. Error, cannot find symbol. And it gives us a little tip. The error is in pizza.java, and it's on line 6. That's what that means. So I can go to Notepad, go to pizza.java, and it's on line 6. So what is wrong with this picture? The S in string is not capitalized. This is actually a pretty good message, all right, because it even uses a little caret to show you, hey, there's something wrong with that letter, all right? Especially people starting out. Having things the wrong case is going to be, is often a cause for many of the errors. Let's do this again. That was fun. All right, let me save everything. Compile it again. Oh, I did the same thing. Not what I wanted to do. Pretend you didn't see that. This I like. Believe it or not, I just changed one thing. And I'm getting 4 errors. How are we going to debug this? Where do we want to start looking? Other way around. All right. And it's not the return value, it's the argument. So what this is telling you is I'm giving it an argument of a Boolean, and yet the function is expecting a string. All right. So I'm giving it an argument of a string, and I'm trying to put that in a Boolean. So I would look by looking at number 16 on that. I made a mistake here. I said public void set has pepperoni string as an argument, right? Now, has pepperoni is a Boolean, and therefore the argument of the set command ought to be a Boolean. All right, we'll do a couple more of these. I'm trying to create really confusing ones, but I have a feeling I'm not creating them confusing enough. You'll see confusing error messages soon enough. All right, what do you suppose that is? Pizza, Java, line 41. So I look at that, line 41. That's a curly bracket. What's wrong with that curly bracket? Thoughts? Exactly. There's nothing wrong with the curly bracket per se. The problem is because we define that that function returns a double, by the time you hit the end of that function, you better have returned a double, right? And therefore, it's going to give you an error. So I actually removed return bake time. We'll do 2 more. I think I said that a minute ago. That's not the error I intended to get, but good enough. Variable name cannot find symbol. Bake time equals 10. All right. Yep, I got rid of where I defined it as a double. In fact, if I don't have this in there, I'll bet I get an error too. Oh, no, I don't. You're right. It's set by 0 by default. Let's see, last error. This is a good one because it doesn't really, this is a very non-descriptive error. It's a good example with what I was trying to create. It says in line 44, class interface or enum expected. Let's look at that. And it says line 44. Oh, no, I didn't do anything with that. I kept that in there. This one's tricky. I have an extra one of these braces at the bottom. Therefore, this brace here goes with this brace up there. So I finish this class and I might have another class underneath it, but I don't. A good way to show that is notice when I put the cursor right after that, at least in Notepad++, it shows, doesn't show that it matches with anything. Whereas like if I put the brace here, it shows that that matches with this one up here. So it does take a little creativity to figure out some of these error messages. But I am there to help. But again, it's always good if you try to figure it out. And it will get easier as you go on, because as you get on, you'll notice some of the errors that you make over and over again, and you should be able to take care of them. All right, do we have any questions? All right, I'll see you up in our lab, which is what? 210? Okay, I think it's 210. We'll see you up there.